So now we have, we're stating the possible rational zeros for each function. Now this is just possibilities, okay, possibilities. So this is just a list. Notice how the choices here are just lists. These lists spring from the rational root theorem. All right. So the rational root theorem says that if I took the tail of the polynomial and identified all of its factors and took the head of the polynomial, identified all of his factors, both positive and negative, so all positive and negative integers, okay? And what I do is I put them on top of each other, all right? So P will go over Q in alphabetical order, okay? And what we do is carefully, we take the 1 over 1, which is just 1 over 2, 1 over 3 here, then 1 over 6. Now those are my possibilities. That's it. There's nothing else that I have. So if I wanted to find the root, which is what happens when you do find the root, which is positive and negative, you got to find those roots. No. Looks like you don't have to. You don't have to find them. You don't have to actually find them, unless 23 and 24 kind of count as that. But the possibilities for rational zeros, never mind complex or irrational ones. Those are entirely different things. Okay, and those do not apply to the rational root theorem. Because remember, we can have, plus and minus, those conjugate roots there. Those can happen, but they don't happen in the rational root theorem. Okay, those will come up through other means. Okay, so the only choice here that we have is A. Now here we look and see the tail, it's 13, and we see 4. So what we've got is we only have 1 and 13. In Q we have 1, 2, and 4. Those are just the factors of the, now 13 is prime, so there's only 1 and 13. And then 4 has 1, 2, and 4 will go into 4. All right, so let's put them over each other. P over Q, what are the possibilities? We've got 1 over 1, 1 over 2, 1 over 4. Okay, then we have 13 over 1, 13 over 2, and 13 over 4. Okay. Now, we don't even have to do synthetic division for any of these, thank goodness, because, doing it with a fraction is kind of a little unnerving because you think like something's wrong, but nothing's wrong. These are possibilities. And, if you can actually, it's easy to do in a spreadsheet. But anyways, we've got 1, 2, 3, 4, 5, 6. It looks like 1 and 13, 2, the 2 2s, and then the 2 4s are right here. So the answer is B. All right. Now we go to 21. And this is Descartes' rule of signs. So Descartes' rule of signs is very simple. Everything always occurs by 2's. So if your answer is 4, your ultimate answer would be 4, 2, 0. If your answer was 3, it would be 3 or 1. Okay, it's always by 2's, right? Now the reason for that is because everything occurs in pairs when you're dealing with conjugates, right? So if it happens that one of your roots is a complex number, then there's a pair of them. So therefore, you have to move by 2's, okay? So it's just a quick little rule. It's pretty simple. What you do is you look at how many sign changes for the possible positive, okay? So that's just directly, okay? So for positive, it's direct counting of sign changes. Now for the negative one, that's going to require something else. So for that, we'll do something differently. But anyways, let's count how many sign changes actually occur here. This positive, positive, some no. Positive, negative, okay, that's 1. So positive, negative, 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 nope. Negative, nope, nope. So it looks like I have one possible positive real root, or real 0, same thing. So 1, 1 looks like it can't be B, it can't be C, it's got to be A, D, or E. So now, the only tricky thing now is to count the negative ones. Now it's not so hard if you kind of figure out the pattern here. What you want to do is you want to put a negative x for each one of the x's. Now, you don't have to write this out. You just have to follow kind of a rule of thumb. It essentially works like this. If the power is an odd, then you're going to change the sign. All right? If it is not odd, i.e. even, then you will not change the sign. So for example, this guy, the 12 was positive, but notice I put in a negative x for x. Each x became a negative x. Now, you don't have to write this out if you just think of it like this. If a negative x was raised to the 5th power, he would be still negative, right? So this positive 12 would now become a negative 12. But when I go here, a negative x is irrelevant because negative x times negative x times negative x times negative x, that is negative x to the 4th power, in parentheses, will stay the same. It will not change its sign. So positive 8 will not become a negative because x is being exponentiated by an even number. So he will stay as he is, which is a positive. Here, a negative sign means that the sign, that negative, will output a negative. So therefore, this guy here would become a positive. So a negative times that new negative would become positive. All right, now here, x to the 2nd, a negative number raised to an even power, would not change him. Okay, then we go to here, a negative power here would change him, so that would become positive. That a negative x does not change him, he is negative. So now we count the sign changes. So this is a little bit trickier, but there's plenty of videos online that maybe somebody else can explain it better, but it's just, if it is a odd power, the sign changes. If it's an even power, it doesn't. So write out what you have now, then count the sign changes. All right. So here's 1 change. Nope. 2, 3, 4. You have 4 changes. Okay. Now it doesn't just mean 4. It means 4 or 2 or 0. All right. They have to kind of come in pairs. All right. Just because of the nature of the complex and irrational conjugates. Okay. So we have 4, 2, 0. Looks like right here. That's 5, 3, 1. Nope. 6. Nope. So 4, 2, 0. So it's got to be A. I'm going to do the same thing here. Okay. Now what's nice about this is even though you have missing degrees here, it doesn't matter. It won't matter. So let's look at this guy. How many sign changes do you have here for the possible positive ones? 1, 2. So it's 2 or 0, right? So 2 or 0, possible, positive. So check, check, check. So we can cross out D and A. Now for the negative, all right? So again, if I made this x a negative x, he would be raised to an odd power and therefore change this positive 8 to a negative 8. An even power does not change the x, so he will remain a negative. An odd power would change this to a negative, so therefore it would make him positive. And the 1 is going to stay positive. So how many sign changes? 0, 1, also another 0, so a total of 1. So we don't say 1 or 0. Remember, we always go by 2's. So we have 2 or 0 positive, 1 negative. So 2 or 0, 2, nope. 2 or 0, not 3 or 0. 2 are 0, 1 negative. So your answer is E. Okay? And then we will do the last 4 in the last batch.